Hello everyone and welcome to the study session devoted to economics in CFA Level 1 exam. Today we are talking about microeconomics and the reading is topics in demand and supply analysis. Let us first go through the overview of economics in CFA Level 1. CFA Level 1 covers two areas of economics: microeconomics, which studies households and firms and their interactions, and macroeconomics, which studies national input and national output on the basis of microeconomics. Logically, we start with microeconomics, and today we will take both customer and firms perspective and discuss demand and supply analysis. As said, consumers and firms, which are studied in microeconomics, are interdependent between each other in their decisions. For example, consumers or households take decisions on how much quantity of a good to purchase, and they do this by utility maximization. Firms, at the same time, try to maximize their profit and to decide how much of a good to produce. As soon as the decision of the firms influences consumers and vice versa, the decision of consumers influences firms, their behavior is, of course, interdependent. On a higher level, microeconomics and macroeconomics are, of course, interdependent too, because consumers and firms, as a units of microeconomical analysis, interact and play a role for national output and national income, which are at the core of macroeconomics. We start with microeconomics and with the perspective of consumers. So we take a step back and consider demand, which consumers position for firms. And the first question which we would like to answer is: what quantity Q of a good X are consumers willing to purchase? And the law of demand, which holds only with some small exceptions, says that as soon as the price of a good rises, the consumers will tend to purchase less of this good. However, the quantity purchased doesn't depend only on the price of this good. It also depends on the income of customers and prices of some other goods, which can be substitutes of the good X. On the figure here, you can see the function of price on the quantity, and this function is linear decreasing, which tells us that as soon as the price is higher here, the quantity purchased will be lower. As soon as the price is lower, the quantity purchased will be higher. And of course, in real world, the dependency is not linear, but a complicated function. But to some granularity, it can be approximated by linear functions. The next question which we would like to answer is what is the effect of a change of the price to a change in the quantity? And as soon as we consider function Q not only as a function dependent on the price of a good X, but also as a function dependent on the income of the consumer and on prices of some other goods, we consider three types of elasticities in CFA Level 1. And these elasticities are the reaction of the quantity to purchased to a movement in a price. Let us first take a step back and think, how could we describe the movement in quantity with respect to the movement in the price? And the logical answer would be just by a derivative or tangent line towards a function, which would be, in our case, delta P divided by delta Q, so change in price divided by change in quantity, or vice versa, change in quantity divided by change in price. But both these measures, which are tangent or cotangent lines to this function, are dependent on the units which we use. For example, prices are quoted in dollars, it will be dollars per unit. And prices quoted in Swiss francs will be Swiss francs divided by units. And in this case, we will not be able to compare between these measures for different countries, for example. And that is why a very important concept presented in CFA Level 1 takes into account the percentage movements of the quantities and the percentage movements of the price, which neglects actually the effect of measures of particular prices or quantities. So let us start with the own price elasticity, which tells us by how much percent the quantity of good X will vary if we change the price of a good X in the percent also. For example, if one changes price for the good X by 1%, by how many percent will the quantity purchased of this good change? The cross price elasticity is the reaction of the quantity purchased of the good X to a movement in a price of another good, of a good Y. For example, if the price of Coca-Cola rises, one tends to purchase more of Pepsi. And in this case, the elasticity, this measure would be positive. And we can say that Pepsi is a substitute of Coca-Cola and Coca-Cola is a substitute of Pepsi. However, if the relation would be negative, it would mean that as soon as the price goes up, the quantity purchased of another good goes down. And it means that the products are actually complements. For example, this can be cars and tires. If the price of cars goes up, one also purchases less of tires. And the third concept is income elasticity, which tells us about the movement in a quantity purchased in percentage towards the percentage movements in income. Here, one can also distinguish between different types of goods. For example, if my income grows and I start to purchase more of a good X, this means that the good is normal good. However, if my income grows but I start to purchase less of some good, it tells me that the good is inferior good. So from here, you need to memorize that normal goods and inferior goods are coming from income elasticity and not own price elasticity. And about substitution effect and complements, you can decide from cross price elasticity. This is very important, and we will see why in the later slides. Before we go to the next slide, first of all, note that actually the own price elasticity, it can be rewritten in the following form. Because the percentage change in quantity can be written as the change in quantity, absolute one, divided by the quantity. And percentage change in price can be written as the absolute change in price divided by price. And that is why we can write this as a cotangent of this angle here, multiplied by price itself and divided by the quantity. As soon as cotangent of this linear function doesn't depend on the point where it is computed, cotangent is fixed in this equation. However, px divided by qx obviously depends on the point at which it is computed. And it means that overall the elasticity, the own price elasticity, depends on the point where it is computed on the function. It is very important. Let us see how it influences the elasticity and what functions you can consider for describing the relationship between price and quantity. First, let us understand what is actually what is an elastic demand and what is an inelastic demand. For this, consider a 1% change in a price of a good X. If the quantity purchased changes by more than 1%, so it reacts stronger, then it is an elastic demand. If the change in 1% change in price leads to a smaller change in quantity, it means that the demand is inelastic. It doesn't move so fast as the price moves. Let us get back to the linear function from the previous slide. And here you can see that at each point, the cotangent line would be the same, but at the same time, the px divided by qx would be different. And there would be some point at which elasticity would change to inelasticity in terms of demand. Let us assume that the angle here is 45 degrees, though it's not, as you can see. In this case, if it is 45 degrees here, it means that it is also 45 degrees here. And cotangents is equal to 1. And px divided by qx is equal to 1, exactly the midpoint of this graph, because p is equal to q in this case. And it means that elastic demand changes to inelastic demand exactly at the midpoint. Now let us consider two degenerate cases. First case is when our demand line is totally horizontal. In this case, what is important to understand is that the firm can actually sell any quantity, even infinite quantity, but exactly for this price. And as soon as a firm wants to increase the price just a little bit, it will have demand equal to 0. Nobody will buy anything. Mathematically, in this case, angle is equal to 0. Tangent line, which is delta p divided by delta q, is also equal to 0. And elasticity, as soon as it is cotangents here, not tangents in this case, it is infinity, so 1 divided by 0. Oppositely, if we have a vertical line, it means that the price can move as it wishes, but the quantity purchased will stay the same. So customers will not purchase more or less if one changes the price. In this case, the angle is 90 degrees, tangents is infinity, and elasticity is 0, which means it is perfectly inelastic. So coming to firms a little bit, the horizontal line tells us about perfect competition, because in the perfect competition, like in the markets of corn or wheat, one cannot increase the price and stay in the market. One will be pushed out. However, vertical line tells us more about monopolism, because the price can be set arbitrarily if there is no governmental intervention in this, and the quantity will be still the same. Now, let us come to the total expenditure, and note here that we are not talking about elasticity of total expenditure, which would be, of course, the percentage change in total expenditure divided by a change in a variable price, for example. However, we are just talking about the value of total expenditure. And what is again important to note, that in our linear function, we have a point at which elastic demand switches to inelastic demand. And it is important to remember that in elastic case, the small change in price leads to a larger change in quantity. And in an inelastic case, the same change in price leads to a smaller change in quantity. And what it means that in an area where the demand is elastic, we are multiplying change in price by a larger amount, and we are increasing in total expenditures. But in an inelastic demand case, we are multiplying the same change in price by a smaller Q, and that is why we are in a decreasing setup. So the total elasticity looks like a bell-shaped function, and it is increasing until the point where the demand switch from elastic to inelastic cases. Let us now consider an example which can be asked in the CFA Level 1 exam as a calculation example. Here you are given a function of quantity of electronic books purchased, depending on the price of these books, income of the consumer, and price for hardcover books. You are given a point where you need to calculate all elasticities, because we remember that elasticities are dependent on the point at which they are computed. And we can obviously compute all three types of elasticities, which we consider own price elasticity, cross price elasticity, and income elasticity. Note that here we are given a function Q dependent on P, but not P dependent on Q. That is why we will use tangents and not cotangents. And in the own price elasticity, the tangents is equal to minus 0.4 in the own price elasticity case. And the point is given to you. So this is the point. You place it inside of the function and get the number of electronic books which will be purchased. And you compute it just by plugging in. You receive minus 2.046. In the cross-price elasticity, you do completely the same, but you take a tangents corresponding to the hardcover books. It is 0.15. And here you can see when you plug in the numbers that you get a positive number, which means that the products are electronic books and hardcover books are substitutes. And as soon as the price of hardcover book increases, customer tends to purchase more of electronic books. For the income elasticity, we plug in the tangent corresponding to the income and the income itself divided by the quantity purchased. We get 0.551. Again, in case the elasticity is positive, we are talking about normal goods, which means that if the income rises, the consumer buys more of this good. In this case, electronic books are normal goods. Now, I would like to isolate substitution effect from income effect and to show you that actually the in substitution effect for normal and for inferior goods, you will tend to buy more if the price decreases. Let us consider the example. Suppose there is a customer with income shown by this box here, and this customer spends this amount of money shown with blue on coffee. And of course, he spends some amount of money on some other goods. One can write it like this. Income is equal to price of coffee multiplied of quantity of coffee he purchases, plus the sum of other prices and other quantities, which don't interest us at the moment. Then suppose that the price of coffee decreased. And it means that P bar is smaller than PC. In this case, the customer is actually willing to pay for the option of reduced price, and there is an amount delta. There is also delta, which is equal to the difference of this here and this. And if this delta would be given, there would not be any difference between these two cases. What does it mean? Again, so suppose we have an income, we are paying some amount delta for purchasing coffee for a less amount, for this price, and we now buy some other amount. Let's think if it will be the same as here or not. And the prices of other goods didn't change. Let's think if these amounts will stay the same as well. As soon as the customer decides on the quantity he purchases by utility maximization, he uses either this or this as a constraint. And it is very important that by using this data, we actually reduce the income effect. So we isolate only the substitution effect. The utility function of a customer stays the same, but as soon as he has a price which is lower here now, he will tend to purchase more of coffee than he purchased it with his income I and under the price P. The income effect we managed to reduce by the use of this delta, and the substitution effect stayed because of this price. So one can say that because of this utility maximization and the reduction in the price, the consumer will tend to purchase more of coffee in the second setup, in this setup. Now, it is very important to remember what are normal and what are inferior goods and to what do they correspond. Normal goods and inferior goods tell us about the income effect. So as you remember, if the income rises and one tends to purchase more of a good, it means that we're talking about normal goods. At the same time, if income rises, but one tends to purchase more or less of this good, it tells us about inferior goods. For example, in some suburb areas, it can happen that by increasing a price of rice, one would also try to buy more of this rice because of some internal reasons. Also, it is important to understand that for one consumer, one good can be normal and another inferior, and for other consumer, one good can be inferior and another normal. So for normal goods, the substitution effect tells us that the purchasing will be more if the good is cheaper with respect to its substitutes. And the same is about inferior goods because of the example from the previous slide. However, in the income effect, for the normal goods, if the income rises, you buy more of this good. For the inferior goods, if the income rises, you buy less of these goods. Also, two interesting cases are Veblen goods and Giffen goods. As you can see, Veblen goods are normal goods and Giffen goods are inferior goods. However, these goods are telling us about their own price elasticity, and this is very important. So the initial law of demand from the first slide tells us that one will tend to buy less if the price increases. However, this is not true for Giffen and for Veblen goods. More goods are consumed if the price rises, the own price rises. But there is a difference between goods. First of all, Veblen goods are normal goods and Giffen goods are inferior goods. And also Giffen goods are usually non-luxury goods where income effect is very strong. While Veblen goods are luxury goods such as watches, and as soon as one has one observes a higher price of this good, there is an additional incentive to buy this good. So there are such interesting cases. Now we are coming to the second part of our talk today and to the perspective of firms in microeconomics. In their decisions, firms base on profit maximization. However, their decisions influence the behavior of consumers and vice versa. Behavior of consumers influences the decisions of companies. Now let us come to the second part of the talk, meaning the perspective of companies in microeconomics. Companies in their decisions are dependent on the decisions the consumers took about the quantity to purchase for a given price. However, firms base their decision on profit maximization. First of all, let us go through all the costs the firm faces in order to take their decisions. First is the total cost. For the given labor L with a wage rate W, and for the given capital K with a rate R, one can write the following total cost. It is quite easy to estimate this part, which is a labor cost. However, for the capital cost, one needs to account for opportunity costs, such as costs of renting machinery out instead of using this machinery in the company. The total cost can be subdivided into variable cost and fixed costs. In short term, some costs are fixed and some are variable. In long term, all costs are variable. Average total cost is just the total cost divided by the product, the quantity produced. And again, it can be subdivided into average variable cost and average fixed cost. Here, let us have a look at the graph. The average variable cost goes first down and then it goes up. This happens because adding a productive labor power, one reduces the cost for additional unit. And that is why the initial cost goes down, because the marginal returns are increasing here. However, as soon as one adds too much labor, for example, and the labor starts to contradict in the actions, then marginal returns start to diminish. It is the law of diminishing marginal returns, and the average variable cost goes up. The average total cost, as you remember, is just the sum of average variable cost and average fixed cost. As a cost, fixed cost is of course fixed. However, if one considers this cost per unit, so divided by the amount produced, Q, it will be of course constant divided by Q, and it will be a decreasing function. That is why when we sum up average variable cost and average fixed cost, we first receive bigger differences between the average total cost and average variable cost than in larger quantities. For larger quantities, the difference between average total cost and average variable cost is very small. Then we have marginal cost. This is just the difference in total cost with a difference in the quantity produced. And here it is very important to understand that actually marginal cost will cross all these cost functions, average variable cost and average total cost, at the minimum point. This is because as soon as marginal costs get higher than average total cost, the average total cost will start to increase because you add more to it. However, as marginal cost is lower, so for additional unit of production, the marginal cost is lower than average total cost. It means that the average total cost decreases with an additional unit. So you add a small amount and divide by the product. Further, it is important to remember the following concepts because in CFA level 1 you can be asked to compute them. The total product is just the quantity produced. The average product is in labor is the quantity produced by this labor. Of course, you can be also asked to calculate the average product by capital, and in this case you need to divide the quantity produced by the capital. Then you have marginal product in labor here, and it is just the difference in quantity produced given additional labor. The total revenue is always just price of your products multiplied by the quantity produced, and the marginal return is just the difference in total revenue divided by the difference in quantity produced. We could take total revenue as a function of P and Q and just differentiate it over Q. In this case, one would receive such a function of marginal revenue. Now let us consider two very important concepts covered in CFA level 1, perfect competition and imperfect competition. As you remember from the slide where we considered horizontal and vertical demand curves, this slide is connected to the one before. In a perfect competition, the demand curve is horizontal. It means that by adding a little bit of price, the firm will be pushed out of the market. And the marginal revenue curve is just equal to the price because our delta P divided by delta Q is equal to 0. However, in imperfect competition, our marginal revenue is just equal to this, and delta P divided by delta Q is not equal to 0 in this case. And in general, the demand curve is decreasing if it is not for Veblen or for Giffen goods, for example. And also note that marginal revenue is equal to 0 in such an interesting point where delta P divided by delta Q is equal to minus P divided by Q. Now let us understand what is actually the profit maximization and where does this profit maximization takes place. Here you can see the graph for perfect competition because the demand curve, which is shown by a dashed line here, is horizontal, and it is written that marginal revenue is just equal to P because delta P divided by delta Q is equal to 0. The average total cost first decreases and then increases as the same as average variable cost. The short term, in this case, short term marginal cost crosses average variable cost and average total cost in their minimal points. To receive the profit maximizing quantity, one needs to understand that actually the profit maximization will take place in the point where marginal revenue is equal to the marginal cost, and at the same time marginal cost is non-decreasing. Indeed, if marginal cost, so the function here, the dashed green line, would be decreasing, we could always add additional labor which is productive and increase our profits. However, in the increasing marginal cost part, this is impossible. Marginal revenue should be equal to the marginal cost, because by deviating from this, one would reduce profits. Thus, in order to compute the maximal profit, first of all, one just needs to compute where MR is equal to MC, and this happens at this point. So this is a demand curve, and you sell exactly this amount. What is your profit? Your profit is the difference between how much you sell and how much this costs to you. So this is the difference between this point and the average total cost. This is all. So when you need to solve such problems in CFA Level 1 exam, just first of all, account which type of competition it is, then compute where your marginal revenue is equal to the marginal cost, and then don't forget to subtract from your marginal revenue, from your demand, the average total cost. Now we consider the same concept in terms of imperfect competition. In imperfect competition, the marginal revenue curve is decreasing and the demand curve is decreasing. In terms of perfect competition, marginal revenue is equal to the price and to the demand. In terms of imperfect competition, you can see that this has a difference between them. And marginal revenue, as you remember, is equal to P plus Q multiplied by delta P divided by delta Q. In this case, again, you just need to find where your marginal cost is equal to marginal revenue. This is this point. However, your demand is higher, and that is why, in order to account for the price per unit which you charge, it will be higher than in case of a perfect competition. So you will charge this amount, and you will pay average total costs again. So here you need to subtract average total cost, not from the dashed green line where it intersects the red one, but from the demand, because you sell, you satisfy the whole demand in economics. Now, what is very important to understand as well is where it is optimal for the company to short and when it is optimal to company to continue its operations. There are 2 points. The point where average total cost intersects marginal cost, and the point where average variable cost intersects marginal cost. Before this point, so here, one cannot satisfy a fixed cost and one cannot satisfy variable costs. In this case, one needs to shut down in both long-term and in a short-term run. If one is beyond point T, one operates successfully and makes profit, and at this point, one makes zero profit, but continues to operate in both short run and in long run. And between these points, one satisfies a part of variable costs and whole fixed costs. And that is why one operates in a short run, trying to get over the break-even point, and one stop operating in the long run if the situation continues. One can see this here. So if the total revenue is higher than total cost, you make profit and you stay in market in both cases. If your total revenue is higher than total variable cost, but your total revenue is smaller than total cost, so it means that you satisfy fixed cost, but you don't satisfy the whole variable cost. In this case, in short run, you stay in the market, but in the long term, you exit the market. And if you don't even satisfy variable costs, you need to exit the production and shut down operations. Then I would like to remind you and give you an example for short run operations. In a short run, at least one factor of production is fixed. But in the long run, all factors of production are variable. Let us consider a very small example of three plants. One of them is a small plant for which you have a very small fixed cost, but it reaches capacity very fast, and that is why the dollar price per time unit starts to increase sharply after some time. Then you have a middle plant, which fixed cost is higher than the first one, but it also starts to increase in sharply a little later. And there is a third plant, which is the largest one. You pay a lot for it right now, but at the same time, it allows you to reduce your dollar per time period cost in the long run. Obviously, before you reach the production quantity QA, you need to use the plant 1. Between QA and QB, you need to use plant B. Or plant 2, and in case you are beyond this quantity QB, you need to use the largest plant. So this is an envelope curve which can be drawn from these three curves, and this is how your operations which look like in time. Also, it is important to understand what is economies and diseconomies of scale, because in CFA Level 1, there are questions about this. In economies of scale, you are reducing your cost per unit, and you are following this pattern here. So as soon as your production increases, your cost per unit decreases. In these economies of scale, the opposite happens, and the law of diminishing marginal returns takes place, and you have an increasing pattern of cost per unit. Of course, one wants to avoid these economies of scale, and these economies of scale can happen when the operations are too large, companies too large and managed poorly in such cases. Also, it is very important to remember what is minimum efficient scale. It is about perfect competition, where the company would be pushed out of the market immediately as soon as it operates inefficiently. And in this case, one needs to operate at this point, at the point of minimum here. Otherwise, one would be pushed out of the market. So minimum efficient scale is a minimum point of the long run cost curve, and it corresponds to the point at which a company in perfect competition must operate to stay in market. This covers the reading of demand and supply analysis, and we are going to continue with the firm and market structures afterwards.